Albert Einstein, the Nobel Prize-winning physicist who gave the world the theory of relativity, E is equal to mtwo, and the law of the photoelectric effect, obviously had a special brain. So special that when he died in Princeton Hospital on April 18, 1955, the pathologist on call, Thomas Harvey, stole it. Einstein didn't want his brain or body to be studied. He didn't want to be worshipped. He had left behind specific instructions regarding his remains: cremate them and scatter the ashes secretly in order to discourage idolaters, writes Brian Burrell in his 2005 book, Postcards from the Brain Museum. But Harvey took the brain anyway, without permission from Einstein or his family. When the fact came to light a few days later, Harvey managed to solicit a reluctant and retroactive blessing from Einstein's son, Hans Albert, with the now familiar stipulation that any investigation would be conducted solely in the interest of science. Burrell writes, Harvey soon lost his job at the Princeton Hospital and took the brain to Philadelphia, where it was carved into 240 pieces and preserved in celluloidin, a hard and rubbery form of cellulose. He divvied up the pieces into 2 jars and stored them in his basement. Just when you think this story can't get any weirder, it does. To fast forward a bit, come 1985, Harvey and collaborators in California published the first study of Einstein's brain, claiming that it had an abnormal proportion of 2 types of cells, neurons and glia. That study was followed by 5 others, the most recent published just this month, reporting additional differences in individual cells, or in particular structures in Einstein's brain. The researchers behind these studies say studying Einstein's brain could help uncover the neurological underpinnings of intelligence. But that premise is nonsense and the studies are bunk, at least according to Terence Hines, a professor of psychology at Pace University. A couple of weeks ago, Hines presented a poster at the Cognitive Neuroscience Society annual meeting outlining all of the ways in which each of the 6 studies is flawed. Some highlights. In the original 1985 report, Harvey and his collaborators found that in Brodmann Area 39, a region where the temporal, parietal, and occipital lobes meet, Einstein's neuron-to-glia ratio was significantly smaller than it was in the same area in 11 control brains. But the control group was not all that well controlled. The brains came from people aged 47 to 80 years old, whereas Einstein died at age 76. The control's brains were also fresh, whereas Einstein's had been languishing in basements and beer coolers for 3 decades. Perhaps most problematic, counting cells is a subjective business, and the researchers performing the cell counts were not blind to which tissue was Einstein's and which was not. In 1996, Harvey partnered with a scientist from Alabama and counted neurons in Einstein's Brodmann Area 9 part of the frontal cortex, as well as those of 5 controls. There were no differences in the number of neurons or the size of neurons, the study found, but Einstein's tissue was thinner than controls. More densely packed neurons, the authors speculated, means that cell-to-cell messages travel shorter distances, which might mean faster processing speed overall. That's quite a stretch. As Hines calls out in his poster, the finding was based on just 1 square millimeter of Einstein's brain. What's more, the authors admit to not reporting any of the ways in which Einstein's brain was similar to controls. In 1999, Harvey and Canadian collaborators got Einstein's brain into one of the world's most prestigious medical journals, The Lancet, based on old photographs that had been taken of Einstein's brain before it was cut up. The researchers claimed that Einstein had an abnormal folding pattern in part of his parietal lobe, a region that has been linked to mathematical ability. They also reported that his parietal lobes were 15% wider and more symmetrical than those of control brains. Once again, though, the researchers were not blinded to which photographs showed Einstein's brain. And though the authors were quick to make links between these supposed differences and Einstein's mathematical prowess, Hines points out that Einstein wasn't, in fact, a great mathematician. The underlying problem in all of the studies is that they set out to compare a category made up of one person, an n of 1, with a nebulous category of not this person, and an n of more than 1. With an n of 1, it's extremely difficult to calculate the statistical variance, the likelihood that, for example, Einstein's low neuron-to-glia ratio is real, and not just a fluke of that particular region and those particular methods. Even if the statistics were sound, you'd still have the problem of attributing skills and behaviors to anatomy. There's no way to know if X thing in Einstein's brain made Einstein smart/dyslexic/good at math/you name it, or was just an X thing in his brain. It makes me angry to think of all that was wasted in these investigations. There was the monetary cost of the study's money that could have been spent on work that was not doomed from the outset to fail. There was a personal cost in that Einstein's family was essentially strong-armed into agreeing to participate in research that Einstein explicitly did not want to participate in. And there was a public cost, too. In popular press accounts of these studies over the years, the public was misled about the findings and their supposed scientific value. Here's how smart Einstein was. He understood all too well the public's obsession with him, our obsession with celebrity and specialness. He knew that if given the chance, scientists would pore over his brain's neurons and glia, sulci and gyri, and make grand pronouncements about what makes a genius. And he knew it would be bullshit. As Einstein supposedly wrote, but probably didn't really write, on a blackboard in his Princeton office, not everything that counts can be counted, and not everything that can be counted counts. For more information, like and subscribe.